Hey everyone, I'm Akshat, and in this video, I'm going to walk you through the procedural map generation system we built for our upcoming game, the Drawstring Dungeon. Inspired heavily by Slay-the-Spire, but evolved with our own design rules, validation, and challenges. I'll talk about how I generate the map for this game using graphs, layered pathing, and what kind of constraints it was designed around, and some tricky bugs that almost broke our system. First off, it was clear that we wanted a structure similar to Slay-the-Spire, a multi-layered map where each layer has multiple nodes and these nodes connect to the next layer to form a direct acyclic graph. Each of these nodes stores a unique ID, layer index, and a position vector for the UI layout of this map. The core of this map is the connected node list, which stores a direct reference to the other nodes in the next layer of the map. The layers of the map are procedurally generated with Perlin-style randomness for the node count per layer. This is followed by logic to ensure there are no orphan nodes and every path flows downwards cleanly and connects to the final boss. Once the graph structure was in place, the next challenge was maintaining design integrity, meaning fixing site variety and redundancy. We have 4 enemy sites: normal enemy, elite enemy, checkpoint enemy, and the final boss. A shop site, and a random event site which can result in different encounters, including but not limited to fights, bounties, rewards, and penalties. Inspired by Slay-the-Spire, we wanted our map to reflect a sense of progression and control randomness, where early choices matter, and the pacing shifts as you move forward in the game. But I also didn't want the player running into 2 shops, or 3 or more events, or 2 elite enemies back to back. This would break rhythm. So I ended up building a system consisting of multiple functions which enforced site placement constraints across this map. Of course, these constraints were not one-off fixes, but were applied across the map during different stages in the generation. These constraints can be summed up in 5 points. 1. Each node is assigned a site type based on its position in the layer structure. Early layers lean more towards the enemies, while later layers unlock shops, events, and elites. 2. Before finalizing, the assigned type is evaluated against the recent site history in the same path, preventing consecutive shops and triple events. 3. If a rule is broken, the type is swapped for the next best option that fits both local and the overall layer logic. 4. These corrections resonate through the graph to make sure one fix does not invalidate other paths or create unreachable branches. 5. Once the map is generated, a final pass replaces specific enemy nodes to guarantee a balanced number of checkpoints and elites across the map without placing them in the early layers or next to each other. The constraints mentioned previously are put into play during the node connecting. Even though the site rules were working, I happened to realize a major oversight in my connection logic. They looked like a spaghetti mess. Though enforcing the rules, the nodes were connecting to far-off nodes in the next layer and choosing a number of connections per node randomly. This was creating a tangled and overlapping mess of lines, resulting in confusion in the flow of map. To fix this, I introduced a ratio-based connection system, so each node connects only to 1 or 2 nodes in the next layer, prioritizing central alignment but adding variations using max 1 node to either left or right as the number of nodes per layer vary. A small trick was played by my own code here. Though easy, the issue gave us quite a bit of trouble. Some nodes didn't end up connected at all, a topological issue. So instead of fixing it, I ran a pass to prune all unconnected nodes completely to make sure every part of the map is reachable top to bottom. As the player progresses deeper into the game, the map evolves. I mean, not visually it will remain the same. But what I mean is it's not only about reaching the final boss anymore. Certain types of events are introduced that affect the gameplay progression and the map. Bounties can be started now, which, visually marked on the map, encourage players to route towards them for special rewards. This adds a special layer of sub-objective planning. Then come dynamic events like Blackout and Earthquakes. Blackout event hides all the map layers except the next immediate one, disrupting visibility and making it harder to plan ahead. Earthquake event disables specific nodes after generation, blocking what might have been a preferred route. These blocked nodes are only revealed when the player nears them. These systems make sure the map isn't a static route, but an enjoyable journey. Players must adapt their strategies mid-run based on limited information, shifting rewards, and disrupted path. This keeps decision-making tense until the very end. To survive this unpredictability, players have access to an extraction mechanic. They can extract up to 3 times during a map run. Extraction restores full health, but returns the player to either the start of the map or the last checkpoint node they reached. Now what makes this mechanic compelling is that the previously explored part of the map stays marked. So same path, same enemies, and same events. Players can retrace a known safe route or gamble on pushing forward again under different conditions. When used alongside events like blackout, where visibility is limited, or earthquake, or the key routes may be blocked, extraction becomes more than a fallback now. It's a calculated tool that lets the player reevaluate and reroute strategically within a known structure. So that's the system, a procedurally generated rule-driven map that becomes more fun the deeper you venture. I hope this gives you a glimpse of the kinds of system thinking that goes into making something as simple as a map. In case you would like to playtest the game in the coming weeks, join our Discord. Thank you for watching.